Section 2.4, Rates of Change. So to start off this section, we're going to start by talking about what is rate of change. So we need to recall how we determine distance based off rate and time. So recall that distance is equal to rate times time, where this is distance, R is the rate, and T represents time. So if we want to determine the rate given this equation, we can rearrange the variables and write it R is equal to distance divided by time. So if you went 100 miles in an hour, you would go 100 miles an hour. So in order to find the average rate, we take the distance and divide by the time. So again, if we drove 100 miles in 2 hours, the average rate would be 50 miles an hour. However, in reality, you probably start off slower, get it to a max speed, and then have to slow down at the end. So now we're going to talk about how to relate slope in terms of distance and average rates. So slope is again the change in y divided by the change in x. This is another way that we can actually represent average rate of change. So moving on to example 1, we want to determine the average rate of change of the function f of x equals x cubed divided by x over the interval 1 to 3. So if I graph this function x cubed minus x, what I'm looking to do is find the average rate of change between 2 points. So when I plug in 1 into this function, I get 0, and when I plug in 3, I get 24. So to see that better, I'm just going to change our viewing window a little bit. So now keep in mind, this is counting by tens, and this is still counting by ones. And so I want to connect these 2 points with a line. So now you can see that this is the average rate of change between these 2 dots. And you can see we get the slope of 12 for that line. So when we find the average rate, we should get 12 because, again, we're finding the change in y over the change in x. All right, so let's actually work it out. So we have that the average rate of change is equal to the change in y divided by the change in x. And so more commonly, this is just known as slope, which is f of b minus f of a divided by b minus a. So now we're just going to plug in and substitute in for our values. And we get this is f of 3 minus f of 1 divided by 3 minus 1. So f of 3 is 27 minus 3, which is 24. F of 1 is 1 minus 1, so we get 0 divided by 2, which is 12. And that's good because that matches what we got with our graph. So now on your own, I want you to try to determine the average rate of change for f of x equals x cubed plus 1 over the interval 2 to 3, and then over the interval negative 1 to 1. All right, let's give it a try. So again, the average rate is equal to delta y over delta x, which just becomes f of b minus f of a over b minus a. And so for the first one, we get that the average rate is 19. And now let's go ahead and solve part B. And so we get the average rate of change then is 1 from the point negative 1 to 1. Example 2. Before we begin example 2, we need to recall what the definition of a secant line is. So a secant line is a line that intersects the line at 2 places. The slope of the secant line is the average rate of change between the 2 points. So basically, again, we're just going to be finding slope. So here's a graph that's a continuous function. And what we're going to do is we're going to find the average rate of change between these 2 points on the graph. So what we're going to try to do is determine the average rate of change between these 2 points. So in order to do that, we're just going to use the same formula that we've been using, which is delta y divided by delta x. So delta y is the change in y, so 260 minus, and then the second y value is 50. So again, that comes from here and here, divided by, my x values are 40 and 18. And so when you subtract those, you get 210 divided by 22, which is going to give you 105 divided by 11.